Okay, so as Juke has gotten bigger, and as we move towards bigger apps generally, one of the things that you have probably noticed can be a bit of a struggle is like where to keep state. And there are various strategies for dealing with this. One strategy that's become rather popular is to say like, okay, all of the state should live in one place, and that place should be like somewhere central that everything can connect to. So the problem we had in Juke was that like we had like the sidebar and player, which both need to know the current song, for example, in this thing that is like Juke but not quite Juke. And so that state, because it necessarily is shared between siblings, it has to go to the most recent common ancestor, which is the top of the app in this case. And then we have to pass down all these props, which is kind of annoying. Oops. So this state then has to get passed all the way down to like anything that cares about it. And we don't even necessarily know, right? Like at this point, we don't necessarily know that these controls are here and we need to pass down play. It's like a lot of plumbing work to pass everything down through props. So Redux is a library that gives us a solution to this. It actually gives us a solution by using this feature that the React docs are like, you should like probably never use this feature, in that it centralizes all of the application state in one place and then passes it down through context and gives you a way to say, hey, this component cares about this part of application state. And the way it manages all of your application state is through the array prototype reduce method. Well, not exactly, but you describe how you want your application to behave by writing what is called a reducer, which is basically something that you could pass to this array method. Who knows, who can like say what this method even does? Right. So what do I call it with?
Callback.
Right. And what is the shape of that callback function?
I think I've seen it a lot with like adding A and B.
Yeah.
Yeah. So it is the current element, and then the callback is past the current element, and then it's past the next element, and that current element can change according to what you do with that next element.
Right. So it's not quite the current element. That's very close. It's the current state. So, and in fact, here's some. Yeah. So in this case, yeah, it's sometimes called the accumulator or the memo. I'm going to call it the state because that works really well for thinking about Redux. So in the case of a sum reducer, the state is the total. It's the current total. And our reducer function takes the current total and the next number in the array and returns total plus next. So it like just keeps adding on values from this array, and then this return value becomes the next total for the next invocation. In this example, we're taking advantage of the fact that the array prototypes reduce method, if you don't specify an initial state, it will assume that the first element is the initial state, and the second element is the first next value. It's the first thing that's going to get called here. If you do specify an initial state, then that'll be the initial state, and then the first element will be the first element in the array. So this reduces a collection of values into a single one. Redux does basically the same thing, but over time, reducing a series of actions into a single outcome or a single state. So there are three principles when writing a Redux reducer. One is that you cannot have any side effects. So anything anything you want to have happen that is not deterministic, so like network calls or any like randomness must happen outside of the reducer. The reducer must deterministically take a current state and an action and return a state. So it will always return the same state for a given action. That state then never changes. So every state returned by the reducer is like your app at a snapshot in time, and you can't go and mutate it later. And then the store picks up a state and says, okay, this is what the state should be, and it is the single source of truth for them. So the flow looks a bit like this. We have our Redux state that's in the store, which is going to define the shape of our UI. So all of our components are going to listen to it. And one nice thing about Redux is that most of our components can become dumb components, meaning that they reliably and deterministically map between a particular state and a particular view layout. That layout will give the user opportunities to interact with it, which create events, which lead to actions being dispatched to the Redux store, which causes our reducer to run, which generates a new state, which gets stored in the store. So we're going to go through all of that like more slowly, but that is the flow. So let's start here. We have a store. We can create it. Redux gives us a create store function. And so we can create a store which will, by default, have, it'll be initialized with some default state. So let's say that our default state looks like this. We have no albums, we have no artists. Our selected album is an empty object for some reason. Feels like that should be null, but we're not quibbling. This is our initial state. And our React components will listen to that state. And the way they listen is that they call a method called subscribe on the store. What subscribe does is it asks the store, hey, whenever your state changes, you should let us know. So you call subscribe, you pass in a function, and the store is then like, okay, I'll add that function to my list of listeners, and whenever my state changes, I'm going to call all of the listeners. I'm not actually going to call them with anything. The store just says, like, something has changed, you should go figure out if something you care about has changed. So, so how do we do that? How do we create a change? And the answer is we dispatch actions to the store in order to change the state of the store. So if you want to change something, the store says, please call my dispatch method with an action. And actions look like this. They are plain JavaScript objects. They always have a type. And then they have whatever other data we want. So this action describes like adding an album, something we did not do in Juke, I believe. And when we add an album, like we need some information about the album, like its ID and its title and so on. And our reducer is going to use all this information to change the state of the store. This is the only way to change the state of the store. You can't go in and call some method on the state in order to change it. You can't say like state.albums equals some new set of albums. The contract Redux makes you sign, basically, is that the only way you'll change the state is through actions. And in return, what you get is a high degree of predictability. Because you know that the state of your application only changes in these predefined ways, it's easy to log all of the things that are changing the application state and how they change it. It also makes implementing certain features like undo and redo much easier because you have a single object that is, by definition, a plain JavaScript object that represents the whole state of the app. So if you want to go back in time, all you have to do is set the state of the store to be that a state object, and all of your views should cascade and represent that state. Okay, so in our albums view, we have like some button that's like add album, or like maybe when I drop like a folder onto the app, it goes and adds it as an album. And that's going to create, we're going to create an action object, like the one we just saw, and we're going to call store.dispatch with it. So the store says, okay, I got this action, and I know it's going to change my state, but how? And the answer is, like, when we created the store, when we called create store, we gave it a reducer, which might look something like this. Or basically all reducers look something like this. A reducer, like the callback in array prototype reduce, it takes the previous state, or if you like the current state, and an action, and it returns the next state, like what the next state should be. So in order to support our add album action, we might make a reducer like this, where we look at the actions type, and Redux complains if actions don't have a type, so you can safely assume that all actions will have a type. And if we got an add album action, then we're going to copy the previous state so we don't change it. Remember that we cannot change states after they've been created. And then for this new state, we will set its albums to be all of the previous state's albums. This should probably say previous state, but they're the same at this point. And the new album that was included in the action. And then we return that. In the case of any other action happening, we just return the previous state, saying basically we are going to ignore any actions we don't understand by returning, by saying that we just don't change in the presence of them. Questions about this? Like one question you might have is, why is this a switch statement? What's that? Oh yeah, so object assign assigns all of the key value pairs from its second argument into its first. It actually does a little bit more than that. Like if you have a whole bunch of arguments, it collects all of the key value pairs from all of them and puts them into the first. So this is basically a way of making a copy of an object. We could also use the ... like spread operator inside an object.
So sorry, I didn't miss where this reducer is actually. Is this on when you're doing dispatch? When do you?
So you write this function and then you pass it into create store when you create the store. And then subsequently, every time you call store.dispatch, this reducer is going to get called in order to produce the next state of the application. Okay, so we dispatch this action. We call the reducer with the current state, which remembers that initial state we looked at many, many slides ago, which was just an empty array for albums. And then the reducer returns a new state, which should have our album in it. At that point, Redux goes and says, okay, the reducer just returned a new state. I'm going to call all of my listeners. So all of the components that said they care about when the state changes, I'm going to call those functions. And then these components will ask the store, hey, can you give us the new state? Which there's actually another method we need. Can you guess what it's called? Get state? Yeah, good guess. So they all call get state, and then they re-render. That's what re-rendering looks like. And yeah. And then the loop continues, right? So another action happens, and because I click on something, and then another action gets dispatched, and changes their state, and the component is rendered. Yeah. Yeah, you can definitely think of it that way. And in fact, you can, one nice thing about this architecture is that you can, the store is usually just like running in your process. Like it's just, it's not, Redux is not very big. It's just like sitting there. But it could be running elsewhere. It could be running on a server. Um, you could in fact very productively describe a lot of client-server actions as exchanging actions back and forth, or as like one side sending actions and then getting state updates. What are some other things that Redux is good at describing? Redux is amazing at describing games, actually. Anyone who does a game for like your StackDown or like some project in senior phase, a lot of teams end up using Redux because it's a really nice way of structuring what can be very complicated logic, because you can break down almost every game into a set of actions that manipulate state somehow when they happen, or they're rejected, which is another kind of manipulation. You just say like, oh, this can't happen. And most other ways of describing games or complicated protocols, just say games, are they end up being like very hard to reason about or test, whereas this is very easy to reason about and test. Another use case that I think is good is when you're writing a Chrome extension, you will often have like the extension's background process, which is like running in no tab. It's just sort of floating in the user's Chrome session. But then you'll also have some little chunk of JavaScript running in all the tabs that you want to do something to. If you have like if you have a Chrome extension that manipulates the content of pages, and so coordinating the interactions between all of those little worker bees and your queen bee, it's very useful to have Redux manage that. Okay, so in review, the store has a few external methods. Like getState, which returns the state. Subscribe, which adds listeners, and also returns a function that lets you remove a listener. And finally, dispatch, which takes an action and sends it to the reducer, which produces a new state, which calls all of the listeners, and then Redux like invokes all of the listeners, and they request the new state with getState. Damn it. Okay. And that is all there is for Redux. You might find yourself wondering as you're doing this upcoming workshop, why are we doing this? And the answer is actually that it is better for use cases that are more complex than these, I think. Like we're going to be making a chat app, and I don't think Redux is a particularly good use case for that. It's not bad exactly. It does simplify a couple of things, like having the like unread messages indicators, and having the having the chat logs inside of the rooms. But there are probably actually better ways to handle those problems. The things that Redux really excels at are sort of complex negotiations, or any like set of rules that is hard to articulate in a different way. So some of this will feel a little bit like doing your taxes, like filling out, like producing more work in order to ostensibly have like a simpler system in the end. But think of it more as coming to understand this pattern in a, like, with an app architecture that you're very familiar with, so that you can apply it to different structures where it's like necessary to manage the level of complexity that you're dealing with. Okay. Questions? Thoughts? Also, if anyone's interested in Elm, or like, does anyone know what Elm is? If you're interested in Elm, Elm uses a very similar structure for managing state. If you're not interested in Elm, read about Elm. It's kind of cool. Okay, I will make pairs and open the workshop, take a 5-minute break, go put some ice on, have a milkshake,